Hello and welcome to today's Military and Aerospace Electronics webinar, Designing Rugged Cabinets for Mission-Critical Environments, sponsored by Optima Stantron, an Elma company. I am Jamie Whitney, Senior Editor of Military and Aerospace Electronics. To begin, let me explain how you can participate in today's presentation. First, if you have any technical difficulties during today's session, please submit to the questions window and our technical experts will help you out. We recommend disabling any pop-up blocking software or extensions in your browser, as these can cause issues with the webinar player. Additionally, we welcome your questions during today's event. We will answer as many questions as possible during the Q&A session that will follow our main session, but please feel free to send in your questions at any time. To do so, simply type your questions into the question window on your screen and hit the submit button. To refer a colleague to today's discussion, share it on social media, or access event resources, click the icons on the left side rail of your screen. If you would like to increase the size of the windows on your screen, click in the upper right-hand corner of your window. Also, please be aware that today's session is being recorded and will be available on the MAE website within the next 24 hours. You'll be notified by email when the archive is available. Our presenters for today are Cameron Thomas, Mechanical Design Engineer, Elma Electronic, Optima Stantron, and Michael Robitaille, Regional Sales and SME at Elma Electronic and Optima Stantron. Cameron is a mechanical design engineer at Elma Electronic, focused on complex cabinet and enclosure design. After completing his BSME at Vanderbilt University, he joined Elma in his first engineering role, continuing a family connection to the company. Since then, he has developed a strong passion for the technical side of design, specifically in solving complex structural and cooling challenges. Michael has been working in the enclosure industry for over 30 years, serving as a design specialist to help customers solve complex packaging and thermal challenges. As a result of his longevity in the industry, he's become a subject matter expert in collaborating with and delivering consultative solutions that meet and exceed program requirements. So let's start with what our audience is likely asking. When is a standard commercial cabinet not enough? What's the tipping point for when ruggedization becomes essential?
Yep. Yeah. Let me take that one, Jamie, and thanks for the introduction. Looking forward to an exciting session here. It's a great question to start off with. It's a very, very frequent question we get, especially when timelines become critical. There's a short timeline. So what I start to look for are the conditions of where the enclosure needs to be utilized and how, in many cases, how it needs to be deployed. So what I mean by that is we're looking at the environment. Is it going to be subjected to rain, wind, dust, elements like that, temperature extremes? What does it have to survive in that regards? Physical stress is always key. That's the shock and the vibration that it's going to have to undergo. RF EMI, attenuation levels. And then we get into really just the size and the weight of the enclosure, because that can be a key if there's a small envelope or a large envelope that it has to fit. And then as well as that, the payload, the center of gravity, and installation requirements. These can all tip the scale to go from a standard COTS type unit to something that needs to have modifications or a completely ruggedized system. So in those cases, we not only have to take into account the enclosure, but we have to take into account the equipment that's going into the enclosure. We have to look at it from a complete system, because ultimately, as an enclosure manufacturer, our goal is to help the equipment that's inside survive and have a really a long life cycle without failure. So that's the key of the enclosure. So it really, when you've reached that tipping point, it really becomes every ruggedized mill application has to at least be started and looked at as a unique application. It's not like, oh, we did this before, let's do it again here. It has to be looked at as a unique standalone situation, because there's just so many parameters that come into play that have to be understood right up front when we're entering the design phase. Now, it could turn out, hey, yeah, we can go to a COTS because we've digested all the requirements, and yeah, we think something off the shelf might work out. But in most instances, it's going to tip to that. Okay, let's start with a complete design, and we actually just had a recent fairly good example of this where one of our customers came to us with a design need. It was for a satellite terminal control unit. It was going to be a hard mount enclosure. It was going to be a remote install. So a lot of requirements around this thing. But based on their previous generation product, they felt a COTS unit was going to work fine. It had some shock and vibe requirements. They felt, yep, we've installed this before, similar applications, should be a no-brainer. Just design it to meet this envelope, these size and weight requirements, and we should be good to go. So we were a little cautious with that as we approached it. So we were able to convince them to say, hey, let us at least do a structural analysis on this because we're not sure, and we, again, we didn't have a great amount of details except customers saying, yep, this will work.
Mm-hmm.
So we designed the unit based on their requirements. Sure enough, took it to a structural analysis, and it did not pass. So that was very, very disheartening. We had to redesign the units, which was intense, had to go through a whole nother structural analysis. So we ended up adding lead time. We ended up adding cost to this that probably could have been avoided with a lot more due diligence upfront. And I think that's one of the key takeaways is to engage together and understand completely the requirements and not just go by, yeah, it worked in the past.
Right.
We're just assuming it's going to work again. So it's a hard lesson, but we were able to overcome it, develop the unit, and get that into production, and ultimately a successful application. But a lot of learning curve there.
Excellent. Cameron, from an engineering standpoint, what are some of the more overlooked environmental threats that should really influence cabinet design early on in the process?
Yeah, in my opinion, I would say the most overlooked high design impact environmental threat is foreign object debris, or FOD. Most people think of the shock and vibe environment that their equipment is going into. It's not something that's on the back burner. That's something considered paramount at the very beginning. And even when it comes to the EMI requirements, even if it's lower on the totem pole than the shock and vibe, the stress of adding EMI into a design is comparatively low. But when it comes to the prevention of FOD, foreign object debris, like dust ingress into the system, it can actually have a very high impact on the design, and the severity of this criteria can make a very big difference. So on the high end, if you have to meet certain cooling needs, then you would need to have a completely sealed cabinet with an internal heat exchanger so that you don't have air exchange from the outside environment to the inside environment. Because if you have a strict FOD requirement, then air filtration might not be enough. So that takes a ton of internal space away from your equipment. It completely changes the design. Even on the lower end, let's say where air filtration is enough, you still need to have the brackets that hold the air filters. You need to have the filters themselves. You might need to have hoods that protect the outside, that protect the cabinet from the outside environment. And that takes up a lot of internal and external space as well. It determines how far you can open up a door if you're against the wall, how much space you have for the equipment. So it definitely should be taken into account as early as possible. Even with things like what lock washers you can use on the cabinet due to this requirement. Like you can't have tooth lock washers on a painted surface with a strict FOD requirement, because as soon as you tighten it down, the lock washers strip the paint and you have
Flakes.
FOD.
Yeah.
Yeah, exactly. So a very stringent requirement that can have a huge design impact that typically is not given the same priority as shock and vibe. But I do think it can have just as high of a design impact. So that's what I would say might be the most overlooked or maybe underappreciated environmental threat to a cabinet design.
Awesome, thank you. Michael, from a business and program planning perspective, how should engineers and program managers factor standards like MIL Standard 167 or 810 into their cabinet specs
Yeah,
when they're
Jamie,
designing?
absolutely critical. It's absolutely critical to understand these and really to have these communicated as early in the design phase as possible. Now, I'll say in most mill applications, it's really understood. These are going to be called out in a statement of work, even if it's just preliminary. There's always that initial start off, and here's what we're kind of looking for. So we get a feel for what the requirements are. But as I mentioned in the first example, there's cases where there is some uncertainty, and this is where certainly there can be some challenges. You know, we as enclosure manufacturers, really, we possess a wealth of knowledge on how the enclosures are going to perform, what you may need to think about early on when you're in your design phase. So, really engage with us. Let us know what you're thinking about. Let us know what you're doing. We've got the experience to come back and say, hey, did you think about this? Did you consider that? So even when you're working on that statement of work, if it's going to be that formal process, or you just have these questions of, here's what we're thinking of doing, here's what the requirements are, can you help us out? What in your experience has worked, and what maybe don't you need to start to think about? And that's our role. We want to help support that project that you're working on and help make that to be a success. So, the typical requirements we'd be looking for are obviously the program requirements, especially something like a timeline, if you can get into that, because that becomes a challenge. And then the technical requirements. What are the dimensions? What are the mill standards that you're trying to meet, or that you're thinking about meeting? Is there any analysis that needs to be done? What are some of the deliverables? As we get more into the mill side of it, it's, is there an integrated master schedule requirement? Are there design reviews that are going to be necessary? Are there any estrals that we're going to have to meet and contend with? And then certainly quality. Quality is always a big deal. First article inspections, source inspections. What are the requirements there? And ultimately, what would be in a statement of work or a verification or compliance matrix table. That's where we want to get to. So we understand completely. Here's what we're trying to do, and we can come back and say, here's what we feel will help you in that respect. Again, I go back to that first example where it was just a real miscommunication, and you got to be able to learn from that. So my key point here is engage with your enclosure manufacturer early, get them on board, get those questions out of the way, and then once that final RFP comes out and you're engaged in the design, it's going to really go smoothly.
Awesome. Okay, let's talk customization. Many people will assume that customization is going to impact lead times, make them longer. What has Elma done to streamline tailored cabinet designs for unique platforms or footprints? Cameron, did you want to take that one?
Yeah, I can start this off from an engineering perspective. So from the engineering side of things, we streamline the process by working with our standard platforms and reusing our proven designs. Elma's been in the business for a while. Elma has been in business for a while. And with most of the projects Elma has already completed, a lot of times we don't have to reinvent the wheel to meet a customer's customization needs. We already have the frame metal work, whether you need it to be a welded or bolt together aluminum frame, we have it. If you need a sheet metal or extrusion based steel frame, we have it. We have so many custom doors and custom panels in our system that we don't have to start from scratch. We can either use something that's already been designed, something that we already know works as is, or we can take that base and modify it to fit this new pattern. And I know personally, I haven't had to start from scratch on any of the projects that I've worked on, regardless of the level of customization of that project. And with our modular designs, we can put the right custom pieces together around our standard proven frames. And that gives us a path forward to have high levels of customization and operate under constraints.
Yeah, I'll just add into that,
Sure.
Cameron. Those are great points, and it gets to the strength of our product platform and how easy it is to modify that, or I dare say customize that in some instances. So I actually have a good example. I'm full of examples today. I've got a good example of this one, and it kind of goes against everything the questions I've been answering, because this was a situation. Um, the customer's application was for a shipboard isolated mount enclosure. It was really small. It was a small unit, so some of the parameters become easier to solve in certain instances as far as the weight load, the payload there, the center of gravity. But there was no statement of work. There was just the bait. Here's the envelope we've got. Here's the payload we're putting in. How can you help us? And the reason for that was they had a tight deadline to do a destructive test, and they needed an enclosure. So you can't just throw anything at it. We had to go back and look at what we've done in the past, because you want to make sure what we provide them for a solution is going to pass this destructive test. It's pretty expensive, and there's some time and effort going into this. But again, up front, we just didn't have a lot of details. So,
Right.
as Cameron said, the experience we have, the knowledge we have, we were able to look back, find a similar design that we felt super confident was going to meet the application requirements here, and it was going to pass this destructive testing. We were able to pull that together, come up with the design, get that over to the customer for their approval. They came back and said, "Yep, this looks like it's going to work." We worked obviously to get the frame. We worked with our isolation specialist to come up with the shock mount schematic and the correct isolators that we felt would work. Again, no real details there. But we ultimately were able to cut that design time. If we looked at what we would normally do, we cut that design time in half. We're able to get this to the production floor, deliver it in time for them to meet their destructive test, and it all worked out in the end. So, in this instance, it's a little different. The ultimate statement of work will come out later, but they needed something now, and because of our product platform and our experience in the mill world, we were able to come up with something real quick to help them get this thing accomplished and get to their destructive tests. So it was a great success.
Yeah, that's awesome. Okay. One area we get a lot of feedback from our audience on is cooling. It's thermal management. Um, what are the thermal planning considerations when designing these enclosures for high density electronics in sealed or remote deployments? Cameron, do you want to take that one?
Yeah, I can take this.
Okay.
I touched on this a little bit earlier, but when considering cooling for high density electronics, the most important thing, again, to consider is what environmental constraints you're operating under. Are you in a debris-filled environment where air filtration won't suffice, so you need an internal cooling solution? Are you in an environment where the max operating temperature of the installed equipment is just as high as the external environment equipment? So fans can't work because there's no temperature delta on the air exchange. Are you on a ship where you have access to cool inlet water, so a heat exchanger is a viable option? It's just looking at the environment is always going to be incredibly important. Are you installed against a wall where you can't vent air out of the back of the cabinet because there's no area for the air to flow? The environment is always going to shine through as extremely important. And once we consider the external, we can look at the internal to help determine the solution that's appropriate. What amount of heat are you trying to dissipate? Where are the high heat density electronics installed in the cabinet? How much space do you have for a cooling solution? Once we look at the external, then we consider the internal, and we can use all that information to come up with a solution that fits whatever needs arise.
Yeah. Jamie, I just want to jump in here
Sure.
as well. So
Absolutely.
as Cameron said, it's critical, again, to get us involved, because we do have thermal analysis expertise. We can take a look, as Cameron said, at what the parameters are, and help develop a solution. Whether we're installing it or if it's going to be installed at the customer site, or once it's at the installation site. But um, a good example of a situation we had is we were developing an enclosure. It was a antenna array installation. Again, more of a remote site, hard mount enclosure on a rotating platform. A lot of things going on there, but the customer had performed their own thermal analysis. Worked with us to say, hey, we in this situation, we only need a couple fans on the front door, a couple fans on the rear door. That's going to give us the airflow that we need. And we were okay with that. We didn't know what their equipment was in this case, just going by what they were passing on to us. So we designed the enclosure. Everything worked out great. Delivered it. They had it installed, put their equipment in. And sure enough, after installation, it was up and running for, probably just a short period of time, really. And they started to develop temperature concerns. It was getting too hot. The airflow was just not enough with what they had calculated. So fortunately, they came back to us, came to Cameron and said, hey, can you help us out here? We're kind of in a desperate situation. And now it's really challenging because it's already installed.
Mhm.
The good part of this was we had designed the airflow scheme for maintainability. So the fans were mounted on a plate that could be removed. You could remove the filters easily. This was on both the front and the rear doors. So Cameron took a look at it. We were able to get the equipment operating parameters, the external environmental parameters. Cameron did some analysis, and fortunately, in this instance, came up with a solution of we really just have to add extra fans. And with that maintainability design that we had already implemented, Cameron was able to say, hey, we'll just create a new plate, add some extra fans to this, ship them the fan tray. They can pop the other one out, install this one right in the field, easily field retrofittable, if that's a word, and make this thing work. So in the end, it turned out all right. But again, I think it points to the upfront information and analysis that has to be done. And enclosure manufacturers are typically happy to help with that too. We've got expertise there. Even if you think you've already got it, run it by us. We'll help you. We'll help you to either validate or make some recommendations on which way to go. Because again, it's cost and it's downtime that we're trying to avoid. And with cooling, that tends to be a weak point in any system. You've got mechanical fans, they're bound to fail. But in this instance, we designed it for that, and that helped us to solve their ultimate lack of CFN movement within the cabinet.
Yeah, I'm glad for their sake it was a fairly easy fix, that they were able to take care of. But
Exactly.
yeah,
Because
as you mentioned, one of those ounce of prevention versus a pound of cure kind of scenario.
exactly, because
Right.
otherwise you'd be looking at changing, full doors, or or even worse. So it worked out really well in this situation.
Right. Okay, let's shift over to modularity. Beyond manufacturing efficiency, how does modular cabinet design benefit system integrators down the road?
Yeah,
Cameron, jump on that
I
one.
can start this one off too. So our modular designs allow us to make changes and updates without having sweeping effects on the design. We don't have to rework the entire cabinet per se to upgrade the integration to a system. Like, do you need to switch doors to ones with a lift-off hinge, or do you need to switch out side panels so it's removable from the outside instead of just from the inside? You can do that. Like, do you need to change out the I/O panel because you're switching some cable connections? You can do that with a modular design. We have our frame and we have the pieces that build around it that allow for continuous upgrades, which gives you a sense of security within the system. You know that you're given a good proven design up front, but you also know that if the need ever arises, you can make your updates, you can make your changes as they come, because with our modular design, you're never locked in to a certain space. There's always room to grow and improve the system, even after delivery. So I'd say that's one major benefit of our modularity.
Yeah, that's huge, Cameron. I agree. And the self-supporting frame, right? As you said, you stated it clearly. The covers, the skins, they don't make up the structural function of our enclosure. It's within the frame, so it's easy to add on there. And one additional challenge that has come up is, especially on the shipboard applications, and where you've got tight hatchways, tight ladderways, passageways. You're limited by what's already existing there. And if you think about moving a very large enclosure through there, it's virtually impossible. Sometimes the only way to get these systems onto the ship is to blow a hole through the hull, and don't always want to do things like that. So yeah. So one of our customers challenged us with that, and they came in and said, look, you need to come up with something that can be disassembled. Now in most instances we're dealing with a welded frame. That's one of our standard platforms. So that's where the challenge came in, is this thing has to be disassembled, be lower, including the frame, to get it through these passageways. So we took a look at it, went through a complete new design process, came up with a new extrusion that we could bolt together, and this turned into what is now our MB bolt together frame, that passes all mill standard requirements. It's been successfully installed in a number of shipboard applications, so it meets all the requirements. It can be, again, knocked down. So we've taken that modularity to the next level, by coming up with this frame that can be disassembled and reassembled as needed. You can do it at the ship level. You can do it in the shipment. If you're going to ship it to a site, knockdown, we can do all of that. And we develop the disassembly and assembly instructions. We work with our customers closely on that. If they need to come into our facilities and take a look at how we're putting this together to get trained on that, we're happy to accommodate that as well, just to get them familiarity with that. Or we'll go to their site once we ship it assembled, help them disassemble it, put it back together again. So it really is a game changer, and was a game changer for us in developing a new product that just met this particular requirement that was out there, and now it's a standard product for us.
Awesome. Thank you. Many attendees in our audience today are going to be dealing with legacy platforms. What are some of the strategies for upgrading or retrofitting these legacy systems with new rugged cabinets?
Yeah, I'll take that one, because I tend to see that on the front end right away, and
Sure.
where it seems very straightforward, but ultimately it's actually really challenging, because you're not typically replacing one for one. It's not just, hey, this is the system as it exists now, we're changing it with the same system or even the same enclosure. Realistically, the customer is going to be putting new equipment, upgraded equipment inside of it, And once you start doing that, now you're looking at, the payload may have changed, right? The RF EMI requirements may have changed. The cooling scheme may change, which ultimately goes back to earlier on. The cabinet's part of that solution. So the cabinet's more than likely going to have to change. And even beyond that, a lot of customers look at, well, in this cabinet, we didn't have this, we didn't have that. We want to do something, we want to upgrade the cabinet itself. So here's where the challenge comes into place, because while all those parameters are changing, when it's a true retrofit, or you're upgrading, that existing envelope cannot change. And a lot of times how it mounts, which seems kind of simple, but those mounting holes, they're already in the deck, they're already in the bulkhead. You don't want to change those. So now you're faced with a big challenge, ultimately. And again, it's getting us involved early on. What's the environment, and then we can take a look at it. And we had a great example of this, where it kind of combined a couple of the things we were speaking to earlier. With they had a real narrow ladderway. So okay, we want this unit to be disassembled and assembled. We need it to come apart. Okay, it's got to be a bolt together frame. Oh, by the way, it's got to be lightweight. We want to drop the weight of this unit down a lot. Okay, that's challenging. So we took a look at that. With our standard MB cabinet, we had to develop a new extrusion that was lighter weight, that would meet their requirements, and we were able to do that. So there were a couple of challenges. The other challenge is they came in and said, right now when we install this, we have separate isolators for 8 hertz and 14 hertz deck frequencies. We just want to have one set of isolation. Okay, that's a big challenge too. So we're, again, working with our isolation team and coming up with a solution that would meet that. So a lot of challenges, but it was actually a super exciting project to work on, and we did it. We were able to come up with that lightweight bolt together frame, work with the customer on the isolation scheme, develop that, fit into the envelope, and fit into the mounting hole patterns that they required. So it was a super success. It passed all structural analysis. It passed their destructive testing with that one isolation scheme. So really proud of that effort, proud of what our engineering team was able to accomplish. And I think it just shows the level of knowledge and expertise that enclosure manufacturers can bring to the table and help and solve complex problems presented by our customers.
Absolutely. And kind of one overarching theme I've noticed today is some problems could have been avoided with an earlier intervention by you experts, really.
Yep.
What's one thing you wish more program managers or system integrators really asked at the start of their rugged cabinet project design? Cameron, do you want to start with that?
Yeah, I can start that off.
Okay.
One thing that I would say is really important to discuss up front, or a question that I think is important to ask up front, is how we want to work together. A lot of times we're working personally with the engineering team. A lot of times we go through Michael, our sales and project manager, and he's the interface. But I think it's very important to discuss our processes and how we're going to work together, because that really can resolve a lot of issues if we understand our processes and timelines going into it. If you understand how we release things in whole and understand that there's a point where changes become more difficult to make down the line, I think that can be really beneficial and helping orient the conversations that we're having, because we know our timelines, and help guide us in the right direction because you know what we can do. Now, regardless of where we are in the process, we can and will meet the customer's requirements, but as long as you know how we work and we discuss that up front, I think the process can be much smoother. And I'm sure Michael also has some points to talk on about this.
Yeah, no, Cameron, I totally agree with that. And I think we mentioned earlier about the timeline and, making sure we're all on track with that. And, that's what we have a, program management team that's going to get involved and help guide that. But as Cameron said, right from the outset, let's lay that out. And that's part of that early engagement that we've stressed on as well. But I've got my question too, Jamie. So I'm gonna answer that one. It's the question I would love customers to ask is, when can we come visit your manufacturing facility? Yeah, I mean, in my mind, there's no better way for a customer to better gauge what our capabilities, capacities, and competencies are than to get into the factory, see what we're all about, see what we're doing now, see what our processes are, and to meet the individuals that are going to help solve your enclosure problems, help provide that solution, and really engage with them. Because as a enclosure manufacturer of really what's a critical component for our customers, we want to be an extension of their organization. We want to be open, we want to be engaging, and we want to get involved as soon as possible. So it's always with Optima, it's always an open invitation to come into the facilities, sit down, let's meet. We can start that as a design kickoff. It doesn't just have to be come in, but it can start as a design kickoff, design discussions, and go from there. So you meet everybody, the engineering, the operations, the quality, the management, it's program management. It's a great opportunity to do it. I know it's can be an expense, but in the end, it can be super, super worthwhile.
And for folks in our audience, for folks in our audience who might be unaware but interested in visiting y'all, where's your manufacturing facility located?
We have a beautiful campus in Lawrenceville, Georgia. It's a wonderful facility. It's approximately 150,000 square feet. So, again, thank you, Jamie. Always willing to have customers come in. Absolutely, it's awesome. A worthwhile experience.
Okay, and circling back to an issue you brought up earlier, EMI shielding often flies under the radar until problems pop up, really. What are the best practices you recommend to ensure EMI performance is baked into the design of the enclosure from day one?
Yeah, I can take this one. So to ensure that the EMI requirements are met from day one, we designed the cabinet to be a continuously conductive shield, not allowing any unshielding gaps to decrease the shielding capabilities of the cabinet. We plate our frame according to MIL DTL 5541 to ensure low contact resistance between our parts or any, let's say, ground straps from any equipment. We plate our frame, and we also have gaskets to ensure a smooth, continuous contact. Because when you have two joining metals, you're not exactly sure. There could be any surface roughness that could have any gaps in the contact. So we use gaskets to make sure that there's continuous, smooth contact between any joining surfaces. And we make sure that any necessary gaps, like if you have cooling needs, you have fans, any necessary gaps from the outside to inside are shielded appropriately, let's say with honeycomb filters, or if you have cables coming in and out, we have wave guides, just essentially making sure that the entire cabinet is continuously conductive. And we also do things like weld the corners of our sheet metal pieces. Like if you have a door, it doesn't matter if you have a gasket going all the way around the door that connects the door to the frame. If you have gaps on the door because it's a sheet metal part, you have to make sure the corners and seams are welded closed to make sure there's not going to be any unseen or hidden leakages anywhere. So just ensuring that continuous contact is how we approach our EMI requirements for our cabinets.
Yeah, and again, I just add to that. It's I guess I sound like a broken record, but it's always better to get us involved early on that because I get asked that from the front end. Yeah, we need a shielded cabinet, and a lot of times it's just shielding to shield, which is legitimate. But in a lot of instances, it's as Cameron said, we're putting a bulkhead panel on there that's got a lot of cable I/O. Well, we're not installing the cable I/O, so we need to understand early on. Okay, how is that? How are those connectors being grounded or bonded to that bulkhead? Because ultimately, now any attenuation we do could be compromised by all these big holes if those connectors aren't mated right. So we want to make sure we've masked that and appropriately so the connectors have a good fit. Or sometimes the panel's not even on there. The customer's putting that on, developing it themselves. And so, okay, how are we going to mount that to the cabinet? So there's questions that need to be addressed early on, because as Cameron said, RFEMI is a critical component, and we want to make sure we deliver the right solution that's going to satisfy those requirements.
Excellent. Okay, I think we've got time for one or two more discussion points here before we go to our audience questions. Let's go with ruggedization and remote usage. I mean, with rugged enclosures and rugged systems, they're often used in far off remote locations with not a lot of people around to maintain them. What advice would you have for ensuring the maintainability and serviceability in these unmanned or rarely accessed installations?
Yeah, I would say as early as possible in the design, you have to take into account two major things. One is, how do I make sure that this product needs to be serviced as infrequently as possible? And then two, when it does need to be serviced, how do I make that as easy as possible? And that's done by taking into account the service life of the equipment, particularly in our case, the electronic equipment, the moving equipment that we install into the cabinets. And then also keeping in mind that it's going to be real people that are actually using our product on the end. And for example, of the service life, or taking that into consideration when you're designing a cabinet, like the fans will have a longer service life if they're used on the intake side rather compared to on the exhaust side, because on the intake side, they could be blowing in cool, fresh air. And on the exhaust side, they're exhausting out hotter air. And since they're seeing a lower temperature during their operation life, they'll last longer on the intake side. So if you're in a situation where limited serviceability is paramount, we're going to take that into consideration along with the cooling strategy in general. And for making sure our products are as easily serviceable as possible, we come up with innovative solutions with the operator in mind. For example, gaskets that need to be replaced if the need arises. You can have adhesive left over on the frame, let's say, that needs to be cleaned up. So for one of our programs, we designed an extrusion that held the gasket in place, no adhesive necessary, and it made serviceability as easily as unscrewing a couple screws, taking off the old gasket, putting on the new gasket, and then putting the extrusions back on to hold it back in place. There's no cleanup, there's no adhesive. It's a simple process, a simple and innovative design change that made the serviceability easy. And also when it comes to things like fans, the moving equipment that has the chance to fail, if you have to uninstall your equipment and tip the cabinet 45 degrees and angle your arm through a tiny channel like this, that's not reasonable,
right,
as a repair or service procedure. So we have fan panels that can be removed from the outside with captive screws. As you remove the fan panel, the fans come off. You can service the panels from the outside. and then put them back in and install them with captive screws. So just making sure that you're designing with the limitations of the human body in mind, designing with the limitations of the equipment that you're installing in mind, and then seeing the customer as active users is really important. If it's not something that I would be willing to do every day to service the product, then a new design needs to be approached. So I feel like that's very important when trying to make sure that your equipment is low maintenance and easy maintenance.
Yeah. To go back to the gasketing, because to me that was a real, I'm going to say, a genius idea, eliminating the adhesive, because that's the typical point of failure, is that adhesive. So as Cameron said, we've almost eliminated a maintenance item. Yeah, sure, the gasket can still get torn, but in a remote location, if nobody's there, it's probably not going to happen. So we've really eliminated a maintenance process by getting rid of the adhesive, and as Cameron said, making it even simpler to change if you happen to tear it. So that's key. But part of this is also something that gets built in, especially on the military side of it, that gets built into a maintenance manual. We'll work up front with the customers. This is a lot of times part of those deliverables that we spoke about early on, is what's the recommended maintenance on the enclosure. And as Cameron eloquently pointed out, that there's not a lot on the enclosure itself. You might scratch it, you got touch-up paint, you might damage the gasket, you replace the gasket, but a lot of times it comes down to the cooling that's going on inside of it. And so we'll just build that into a maintenance manual and provide that to our customers as well.
Awesome. Definitely appreciate the insights and both of your gentlemen's time. But we're coming up towards the top of the hour here, and we've got some questions from the audience, and
Right.
I would like to jump right in if that's okay with you.
Yeah.
And for our audience, if you'd like to submit a question, type your question into the Ask a Question box off to the side there and hit the send button. And also, as we come to the end of our event today, if you could please take a moment to complete our feedback form that will appear at the end of this event on your screen, we would greatly appreciate it. Thanks. Start with some questions. An interesting asker says, I'm exploring the way environmental resonance and enclosure geometry affects system stability, radiatum/acoustic applications. How might your platform tolerances with vibration, EMI shielding, structural response be applied in a sound/resonance context rather than just traditional defense?
Yeah, I can jump on that. That is a very good question. My initial thought when thinking of that is, we look at the vibrational response of the cabinet during the structural analysis. We look at the natural frequency, which is extremely important when it comes to looking at sound resonance of the cabinet. We can look at the vibrational modes of the side panels to see if there will be knocking or vibration. We look at all the different components, look at the vibrational modes, look at the vibrational frequencies, and we can use that to determine to see where there would be resonance and where there can be ways to mitigate that. So whether that be with gasketing or foam to help reduce any vibration within the cabinet, to help reduce any noise. And EMI shielding can also play a part in that as well. That comes with gasketing of the frame. That comes with, a lot of times it's accompanied with environmental gasketing as well. And I think all of that can play into reducing how the parts interact, whether they vibrate at different frequencies, whether they knock, whether they rattle. And that can also help with noise dampening as well. Just when you're sealing those gaps, it helps also reduce the amount of, air vibration, the amount of noise that gets through, that bleeds through. So those are my thoughts on that question. But that is a very good question.
Yeah, and to add to that, we in the past we have done acoustic dampening enclosures. So as Cameron said, we want to understand the particulars of it, but we have lined some of our enclosures with special foam. Again, want to understand what the end result needs to be, but we have addressed that, and certainly it's within our capabilities to look at that and come up with a solution.
Excellent. And what type of solutions does Elma have for temperature control, your air conditioners, heaters, that sort of technology?
Yeah, so I'll start in saying that we certainly want to engage on thermal solutions with our customers. It tends to be a key part of the overall solution, and it fits in to the integrated cabinet from our level very, very well. So whether it's just simple axial fans or a heat exchanger or an air conditioner, we can certainly engage on that. But we as one of our first examples that I had given, where there was a little bit of a failure there, we want to engage early on that one, and then work with the customers on what's going to be the best solution for them. So we can integrate air conditioners, we can integrate heat exchangers, and we can certainly do mechanical fans. But Cameron, I don't know if you want to add to that. You've got a lot more experience with that, and Cameron has done a lot of the calculations for us in looking at what's going to be sized correctly to meet that customer requirement for heat exhaustion.
Yeah, Michael, I think you covered it well. Fans, heat exchangers, we can do thermoelectric coolers. We can meet whatever needs, cooling wise, heating wise, or the comfort that the customer really needs.
All right, thank you. And what are some of the design differences that you might see between industrial and military cabinet requirements?
Yep, that's a good question. I'm sorry, Cameron, go ahead.
Oh, no. I'll start this off. To me, the biggest differences between industrial and military cabinets would be the geometry of the frame, and the connection method of the joints. When we have the profile of the frame is a very key point, because the frame is the biggest load bearing structure that we have. So we can have extrusion based frames for industrial or military, but the biggest difference there would be the connection method, the joining method. For our industrial cabinets, we could have extrusions with simple bolted connections. And for our military industrial, like our military cabinets, our ruggedized cabinets, we could have welded connections, or we could have bolted methods that are more structurally sound, with extrusions joined by corner keys bolted through those. It's the profile of the frame really determines the rotational stiffness, and the joining method determines how well everything goes together. So I would say if you're looking at an extruded profile, you're looking at a more ruggedized frame. If you're looking at a sheet metal profile, you're looking at a more commercial based system. But the connection method, whether it be welding, bolting, or a more simple bolted solution, will help determine whether you're looking at a ruggedized system or not.
Yeah, and to add on to that, Cameron, those are great points. Is obviously with the industrial, you don't have to meet the mill standards typically. So a lot of times, if you're say going onto an industrial floor, or it's maybe a test bay or something like that, IP could be a requirement. So you're just gasketing it for that ingress protection, but you're not having to worry about the shock and vibe in most instances. A lot of times these industrial cabinets, if it is just a test system, It's going to be on casters and a big wheeled base, so you can move it around. There's some mobility to it that comes into play. But as Cameron said, the frame structure doesn't have to be as, dare I say, robust. And we do have platforms, we with most of the earlier session, we were focused on the ruggedized, the welded frames, as well as the ruggedized bolt together frames. But we have other platforms within Optima where it's really just kind of a swedged together design. It's not truly welded. It's a proprietary concept that we have. It's still an extruded frame, but we just swedge it together, and it's really for that industrial type application, where it doesn't have to meet those stringent requirements. So there's a lot of factors we would look at, and again, recurring factor, engage early so we can understand what is needed, and we've got a plethora of cabinet platforms that we can utilize to help meet both those industrial and rugged mill applications.
Thank you so much. And what options exist for integrated power management inside your rugged enclosures?
Cameron, you want to go with that one, or?
Yeah, I can take that. So it's very common. It's very common for us to have like power strips within our cabinet. Those are very useful, and that can be integrated in different ways, whether it be attached, kind of similar to a rail, maybe attached to the stiffeners going vertical up and down. That gives you a lot of power access, or it can be we have a project that has it integrated within the frame of the cabinet, which gives you access from the outside or the inside. We have I/O panels that give you power access from the rear to the outside. But yeah, from my experience, I'm definitely most familiar with the power strips when it comes to that type of integration within our cabinets.
Yeah, and we can, as Cameron said, power strips are very common, but power distribution units, typical 19-inch rack mount style. We've also worked with our customers where it's going to be external power brought in, but where we've actually put, like GFCI outlets on the cabinets, wired those up to one of those cable I/O panels or a bulkhead, so they can interface that with external power coming in. So there's a lot of things we can do in working with our customers to come up with those integrated power solutions. Some instances, remote monitoring with power as well. So those are things we've looked at, and things we've developed in the past.
Perfect. Thank you so much. And it looks like we are bumping up at the top of the hour here. So for any of the questions we did not have time to answer, we'll be getting back to you via email. And before we wrap up, I'd like to thank Optima Stantron, Elma Electronic for sponsoring today's webinar. And I would also like to let everyone know that Elma will also be sponsoring our next webinar coming up on November 5th at 2 p.m. Eastern. That session will dive into the VNX Plus small form factor module standard and the new QMC mezzanine IO standard. And you'll be hearing from Mark Littlefield of Elma Electronic and Madhu Mikhail of AdLink Technology, who will discuss how these standards complement each other and where they excel in military and aerospace applications, and how you can evaluate them for your next project. More information for that event is located in the resource panel at the bottom right-hand corner of the console. So thanks again to Elma Electronic for their ongoing support of these industry conversations, as well as our presenters today. Thank you and have a great afternoon.
Thank you.